Hey everybody, this video is here to help you out with the Unit 1 Lesson 2 cooldown, which is called a possible geometric sequence. You open that up, it should look something like this. You're given this sequence, and you need to explain why it could be a geometric sequence, and explain what the next term would be, clearly saying how you know. Then you'll answer the learning target assess yourself question. So I've created another one that's somewhat similar over here. So I've given us a few sequences, and we're going to explain why they are geometric or not. So this first one goes 3, 6, 9, 12, 15. If we look at a pattern here, we got to figure out what's happening. We know that to be a geometric sequence, our definition is basically that they have to multiply by the same value over and over again. So geometric sequences multiply by a constant. That's the key thing with them. We're going to multiply by the same number over and over and over again. So looking at this one, I got to think, well, 3 times 2 would be 6. But then when I go times 2 again, 6 times 2 does not equal 9. So this doesn't follow that rule. So this is not a geometric sequence because, well, really the pattern that I see is happening is we're adding 3 over and over again. And so on. 9 plus 3 would be 12, 12 plus 3 would be 15. So this sequence is not geometric because it adds by a constant. Doesn't multiply. So if we have one that's not multiplying by the same number over and over again, it is not geometric. All right, let's look at B. B says 3, 6, 12, 24, 48. Well, let's test and see what happens here. Let's think multiplication. Well, yeah, 3 times 2, like we said earlier, will equal 6. 6 times 2, hey, that works. That equals 12. 12 times 2, that equals 24. And 24 times 2 is 48. So yes, this is a geometric sequence because we multiply by a constant. So we can say, yes, it's geometric. Because this sequence multiplies by a constant. You get from one term to the next. And there's an explanation of why this is geometric. Since it multiplies by this constant 2, we call that number our growth factor. Growth factor in this problem is 2 because we multiply by a constant of 2 over and over and over again. All right, let's look at this last one here. 81, 27, 9, 3, 1. We got to think multiplication here. I can't really multiply by a whole number to get from 81 to 27 because it's getting smaller. So our instinct here would be to realize that this is dividing. If I divide 81 by 3, that gets us 27. If I do 27 divided by 3, that also equals 27. Or sorry, that also equals 9. That works. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3, it's like a fraction symbol, divided by, is 1. So this is following a pattern of division. Our definition of geometric says it needs to multiply it by a constant. So it seems initially like this is not geometric, but maybe we can think of division in terms of multiplication. So if I'm taking the number 81 and I divide it by 3, yes, that equals 27. Maybe we can think of this in terms of multiplication. what would I have to multiply 81 by to get 27? Well, since we're dividing by 3, we can think of that as multiplying by the reciprocal. The reciprocal of 3 is 1/3. This is technically 3 over 1, so we just flip it. This is the reciprocal. If we're dividing by 3, that's the same thing as multiplying by 1/3. 81 times 1 divided by 3 is 27. So that works. So instead of dividing by 3, what we can say is that we're multiplying by 1/3. So times 1/3, times 1/3, times 1/3, times 1/3. So if you see a decreasing sequence and it's dividing by something, instead just find the reciprocal of what we're dividing by, and that's our growth factor that we multiply. So here, the growth factor will be equal to not 3, but 1/3. So that's what we multiply by between each term. So we would say, yes, this is geometric. It's the same reason, because the sequence multiplies by a constant to get from one term to the next. All right, hopefully this helps you. See you next time.